Okay, I've been streaming for a few friends, and a kind of ritual that I've developed is always to pour myself some tea before I start, because it just gives this cozy atmosphere, and I really like that. So I have to remember to share my screen, and then we're ready to go. If I can find my Zoom window, which I can't again. Hang on, technical difficulties. Am I still there? I can't, like, I don't see my Zoom window, so I cannot share my screen, which is a bit awkward. I mean, where is it? I mean, I'm glad you find that funny, but I would...
Nicht alles, mach das mal kleiner.
I only see Alex.
Ja, dann klick doch mal doppelt drauf. Ja, guck mal, klick mal da.
Oh, there we are. Oh man, what a start. Okay, now you should be able to see something. Can you confirm that, please?
Yes.
All right. It's time for the Haxe Winter Report at the Haxe in 2021, part 2. A quick introduction. I'm Krajewski. I've been a Haxe contributor since 2011, so that's actually 10 years now. And I've also been the main maintainer of the Haxe compiler since 2012, so there's also an anniversary coming up next year, actually. We should celebrate that. And last but not least, I'm also a founding member of the Haxe Foundation. All right, with that out of the way, what happened in 2021 since last we spoke? And last we spoke was actually in April for the Haxe in 2021. Since then, we have made a bug fix release in May, 4.2.2, and followed shortly after by the 4.2.3 release in July. And that was the one Alexander actually talked about, where we fixed that bug that caused the compilation time of 3 minutes to go to 45 seconds. And then we had what in German we call it a Sommerloch. I'm not sure how it translates exactly. It basically means that nothing much happened in the summer. And there were various reasons for that, but we recovered in the end. In October, we had the 4.2.4 release. And then in November, we had the haxe-evolution board meeting, which is actually always a big deal. We don't have too many of these. And I want to talk a bit about that and what happens there. So first of all, what is haxe-evolution? Haxe-evolution is basically a repository at the Haxe Foundation GitHub where you can make proposals for what you think should be added to the Haxe language. So if you feel like there's a specific feature that maybe some other language has and Haxe doesn't have, you can try to convince us that Haxe should adopt that feature. And we may or may not agree. That's the point of this meeting, where the core developers discuss the proposals for the Haxe language and then either accept or reject them. It looks something like this when we meet. It's vaguely similar. And haxe-evolution brought us features like arrow functions, abstract classes, and actually quite a bit more stuff. There's a nice list on the repository that you can check to see what we have added. So if you feel like something is missing, go there, make a feature request, but please do it properly, like think it through how it should work. Don't be like, yeah, you should add this and this feature. We need a bit more information or we won't be convinced, I can tell you that. So I want to talk a bit about the accepted proposals 2021 that we accepted there. You can find a detailed overview of what we did in a blog post that Orlon made, thankfully. You can find that in Haxe.org blog. There's also information on the rejected proposals. Today, I only want to talk about the accepted ones, so the talk doesn't get too long. And the accepted proposals 2021, we accepted 7 were, for one, default type parameters by Ben Merckx, then self-access for abstracts by Mark Knoll, then local static variables by Yellow Afterlife, which is probably not his real name. And then it might get interesting here. The null coalescing operator, coalescing. I actually looked that up and I forget it. What is it?
Coalescing.
Coalescing, okay. It's a null coalescing operator. I was told by my Russian colleagues that this is pronounced lynx, like the cat. So I've been saying RBLSB or something. Apparently it's lynx. So I'm going to try to say that because he's going to show up a bit more. Another accepted proposal was the null-safe navigation operator by Robert Borges, and the number separators proposal by this person. And then finally, the numeric literal suffixes by Aidan Lee. And I'm going to go through all of these briefly and talk about what it means. And I'm going to do that in reverse order to really confuse you. So the first one is numeric literal suffixes. What that means is that you can now declare an integer with a suffix, well, not now, but once it's implemented. In this case, you can append I64, and that would mean that you get a hex int64 type without the need to type int that. Currently, it's a bit messy. You have to use an explicit type int in order to achieve that. And once we implement that feature, well, you can just use that. And this is actually a good example of a transform proposal, because originally, the original proposal wanted to have the C-style suffixes like L and LL. And there was some discussion about, that's not really clear. And then somebody noticed, well, it's 2021, and we don't have to adhere to this kind of old stuff. So what we went for now is, we call it Rust style. I'm not sure if Rust was the first one to do it, or somebody else did it first, but we decided to go for this kind of I8 to I64 for signed integers, U8 to U64 for unsigned integers, and then F32 and F64. These are mostly just reserved for now, because what's important here, we're not adding any new types for now. We're only adding suffixes to existing ones. So it would be I32, I64, I forget which unsigns we have. And then on some targets, we have F32, and we do have F64, of course. And there's also already an open pull request by Aidan Lee, who also made the proposal. So he really came through. He made the entire proposal and then also made an implementation, which is great. Then the next thing is the number separators proposal. And that simply allows you to use underscores when defining numbers in your code. In my opinion, it's kind of ugly, but it's also kind of useful sometimes. We thought about that. Well, we came across that after starting to implement it. There's a potential problem here with macro time number passing. And what I mean by that is that when you use a number like that, it arrives like this as a string at a macro, if you pass it to a macro in whatever way. And then if a macro was using a function like parseInt, well, that function might now fail because it doesn't support this kind of underscore. And well, that's not ideal. So we now have to think about, do we want to support this in parseInt and stuff like that? And guys, I'm hearing some background noise from someone. Hold on. Ah, okay, now he's muted. So we would have to figure out if we want to support this in parseInt as well, which is technically a runtime function, but through macros, the distinction is not really clear between compile time and runtime. So we have to be a bit careful here. And then the question becomes, if we adapt parseInt and parsefloat for macros, don't we have to do it for all targets? Because it might work on one target, the macro target, and not on others. And so this is a bit more involved. I'm not sure right now what we want to do here. I have made an pull request for this, which is currently open, and for just the part that allows reading this as a number. And we'll see what else we're going to do with that. Then next up, we're going to be very happy to hear that, the null-safe navigation operator, which basically means you can use a?b as a field access. And this is then the same as a ternary. If it is not null, access a field. Otherwise, just use null. And while this doesn't look too impressive, if there's only a single occurrence, once you start chaining them, it really pays off, because this, if you rewrote this as a ternary, this would get really messy. So it's very useful when interacting in particular with its external JavaScript APIs. And we actually already came across that in the VS Haxe external API because JavaScript tends to deal a lot with null values. So making that a bit easier should be a good idea. And we decided to only accept the question mark dot field access for the time being. The proposal also talked about question mark bracket and question mark parenthesis for array access and calls. We didn't accept or reject that. We're not sure if we want it right now. There are some syntactic implications that we'd have to think about. And personally, I don't think it's worth it because most of the time you're going to want to access a field. And in the few cases where you want to do something else, you can probably find a different way of approaching that. But as I've said, we haven't reached a final conclusion on that yet. And the other thing regarding null is the null coalescing? Coalescing, thank you. I cannot for the life of me remember how to say this word for some reason. But anyway, this was also accepted. And it means that you can use a double question mark. And this then comes out as, if it is null, use the value on the right. Otherwise, use the value on the left. It's pretty straightforward, I think. And it's also very useful when dealing with null-heavy APIs once again. And there's already an open pull request for this by Lynx. And yes, the next one, local static variables. This found a surprising, I found, support among the haxe-evolution voters because everyone was in favor of it for some reason. And it simply means that normally you can only declare static variables on a class. And this proposal aims to also allow declaring them within the function scope. And it works, I think, like in C++. The thing is that these statics are going to live on the class at runtime because they're supposed to be static variables, but you can only access them from within their function. That's what their scope is. There are some issues we have to resolve here related to how we want to handle name mangling, which simply means, well, we cannot just declare loaded textures on this class because it could conflict with something else. There could be already a static variable loaded textures on the class itself, or there could be another method which also has a static variable named like that. So we probably have to prefix it at least with the name of the method. But then there might also be overloaded methods, which is technically supported in Haxe. So we have two methods with the same name, and they could share a samely named static variable, and then we have to work that out. And it's not so obvious how to handle that, but I'm sure we'll figure that out too. Then the self-access for abstracts. And here I want to show you the problem first before I show you the solution. Imagine you had an abstract over int, which has a function x, and then it also has a function y, where you declare a local variable, which is also named x. And now at the place of this comment, how would you call the function x on the abstract? If this was a class, you would have to qualify it by using this explicitly. But with abstracts, you can't really do that at the moment, because if you use this, it's going to refer to the underlying type, not the abstract. And this particular proposal, there were like this many suggestions and many ideas of how this could be done. It was really interesting. And ultimately, we decided to just use the abstract keyword because it made sense to us that if you are within an abstract and use the abstract keyword, you're probably going to refer to the abstract. So in this case, in the example above, you would be able to use abstract.x to access that function. And there's also an open pull request by Lynx, which I'm very grateful for. I haven't checked it yet, but I will soon, I promise. And finally, we have default type parameters. This means that if you declare a class which has a type parameter t in this case, you can now say that it equals int. It's similar to constraint syntax, which allows you to say colon int. So it is constrained to an int, but this equals would mean that the default type parameter is int. So if you make a type hint like final C type hinted to C, this would come out as C int. Of course, you could still use an explicit type, different type, so it could come out as C string. And we, let's I feel like there's one line missing, but I'm sure it wasn't important. I think that said that we only want to support it for type hints for now. There's an open question regarding what we want to do with constructors, because there's some confusion if you have new C and then no explicit type parameters, and then the arguments of the constructor would be used to infer the type parameter. Should it then use the infer type parameters, or should it use the default type parameters? Because technically the latter would be more consistent, but thinking about it, it also seems less flexible and more annoying. So we're not sure yet what we want to do there. And what's also unclear is the support at function level for function level type parameters, because in that case, there's not even a syntax to declare a specific type parameter. So it would likely always have the default, or it would have to be inferred. That's something we still have to figure out. So for now, we're going to focus just on type hints. And there's an open pull request for that by me, actually. And it's a bit messy still, but we'll get there, I'm sure. And that's the accepted proposals from this year's Haxe evolution meeting. I hope you look forward to them. Now, speaking of evolution, I wanted to talk a bit about the evolution of Haxe, of the Haxe IDE support. I find it interesting, if you come to a project or really anything, you tend to take a snapshot of the current situation and then judge everything based on that, because that's all you have. So you don't have the knowledge of people who have been in this project and have seen the development, which can be both a good and a bad thing, because you can have a very fresh view on things, which sometimes allows you to see solutions that people who are more entrenched don't see. That actually happens. That's not just a cliche. But on the other hand, you can be sometimes a bit naive and have ideas that don't really hold up and that people have been thinking about for a long time. And they'll be like, come on, dude, we've discussed this like 15 years ago and it doesn't work. So I want to give you an idea about the history of how Haxe IDE support reached the state it has today. And of course, for that, we have to go back, way back, to 2005, when the Haxe compiler, as a successor to MTask, that was just mentioned by Alan actually, was created by Nicola at Motion Twin. And well, it says Haxe compiler, and in fact, it was a compiler. So what would it do? It would take source code and make some sort of programs from it. I think originally it just made Flash stuff, and then later it made JavaScript stuff and other stuff. But the bottom line is it was a compiler and nothing else. That didn't change until 2007, when Nicola committed in February the -- display for completion. And that was the first time Haxe got any notion of IDE support. This was the beginning. And what it did basically was, if you had field completion, so for example, if you had an empty string followed by a dot, which is a parser error normally because there's a field name missing. Instead of erroring, we would then get this kind of display node. If you don't know how AST works, it's not really important. You just have to understand that instead of erroring, we get some kind of marker in our syntax. And then the compiler can do something with that. And then following in the humble beginnings, as I've labeled them, what you would do is you would simply invoke the Haxe compiler as you would do normally and add -- display. And then the compiler would do its normal thing. It compiles stuff and parses and types files. And if it comes across this display marker that I've just mentioned, it would print some XML to standard error. That XML I'm going to show you, because this one survived for a very long time, and actually it's still around if you somehow manage to trigger it. It simply was a list which held, I think I stands for item probably. They had an N for name. It was important to have short XML, of course. And then it had a type, and if available, it had a documentation. And Haxe would output this to standard error. And the idea was that an IDE could then pick this up and generate a list of suggestions from that and show you these as individual items, which was quite neat. And in fact, I actually asked Nicola about this because I was curious what gave him this idea. I considered it a bit of a novelty when I arrived at Haxe, and that was years later. And in fact, he said, I found it myself while trying to find a solution to reuse compiler logic for completion. I don't know if there are other compilers doing that. So also from his point of view, it was something he thought of. And interestingly, this is still what our IDE support ultimately is based on. So of course, it saw many developments over time. Small progress, like just a week later, actually, the display argument to the compiler received a parameter, which would allow you to state which file and which offset within that file you're interested in. And this offset basically represents where your cursor is. So this blinking thing that you see, this is basically this byte offset. I assume this was because the original thing basically took the first parser error it found and turned it into completion output, I think. And that probably wasn't always what you wanted. You could probably get random completion on something you didn't even look at the time because the compiler just found this parser error. And using this kind of filtering, so to speak, it was now possible to pinpoint where exactly you wanted the information to come from. And that's why it only generated these eDisplay nodes for the given file plus byte offset. And this still works today. If you run this now and have a source file and you find the right bytecode offset, I think you get an XML back. I'm not positive, but I think this still works. And this is from 2007, so that's a long time ago. Of course, Haxe IDE support, well, calling it IDE support at that time is a bit of a reach, I suppose, but this kind of display support, so various improvements over time. There was call argument completion after an open parenthesis, which works very similarly. It just generated some eDisplay node as well. It just checked after the parenthesis instead of after the dot. Then there was also constructor argument completion, which is a similar thing, but worked a bit differently internally. Then this was actually quite important for import and later using statements. You have this kind of thing where you can specify a package or a module, which is an HX file. So the compiler would look at all its class paths and then suggest to you, after you've written import, it would give you a list of top-level packages, which is directories, and modules, which is HX files, and suggest those to you. And then depending on what you did, if you selected a module like the or a package like the hex package, and then did the dot thing, it would present to you all the available packages and modules within that package, and so on. And this was actually really useful even at the time. And some of this stuff was used. I want to specifically talk about FlashDevelop. Now, if you guys were in the room with me, now I would be asking who remembers FlashDevelop, and I'm sure many would raise your hand. I'm looking over at, yeah, I'm looking over at the Zoom call and plenty of people raise their hands. So I wanted to find an old screenshot on an old hard drive to show you what FlashDevelop looked like. And I think I found one which InnoGames people are going to appreciate, because it shows this. On the left, that's the thing that sometimes happened in Flash, and on the right is FlashDevelop. And that's what it looked like. I think that was in 2013. And yeah, I want to talk about FlashDevelop because the Haxe compiler and the Haxe IDE support was actually pushed a bit by FlashDevelop in particular. FlashDevelop has also been around since 2005 and has had Haxe support since, according to my investigation, May 2007. It was developed by Mika Palmo and Philippe Alsace. And it actually had its own completion engine that was pretty fast and amazing. It was somewhat simplistic. It didn't always work. If stuff got complicated, it kind of gave up. But if it worked really well. And then it also had, I just mentioned that, it utilized Haxe to also provide completion. So it has a Haxe-based completion engine that was not fast and amazing by my estimation. And there were several reasons for that. The two big ones were Haxe needed a physical file for parsing because, as I've said, you just did normal compilation independent of the display parameter. So your display file, the information in your display file had to come from somewhere. It didn't magically enter the compiler somehow. It always read some sort of file. And I think IDEs in general worked around that by creating some temporary file somewhere and then pointing Haxe to that. And it wasn't very pretty. It worked, but it was a bit of a mess. And we wouldn't really address this until much later. I'm going to get to that in a bit. The bigger problem actually was that Haxe always compiled everything. Because again, it was just normal compilation. So it would take everything, compile it. And if it happened to come across this, it was still only the eDisplay node at the time, it would show you completion. It tried to focus on the display file, of course. But if your display file, for whatever reason, happened to depend on a whole lot of other stuff, there was a good chance that all that other stuff was also being loaded and typed and parsed. And that might then also trigger more typing and parsing and all that fun stuff. And that made it a bit slow. This was an important issue to address, of course. And well, to an extent, it actually is still an issue today, as I'm sure you're aware. So ultimately, this problem led to the creation of the infamous compilation server, which was first added in 2011 when Nicola committed it. I had some trouble finding this commit because the commit message didn't exactly say what I expected. It said added cache file support and wait on socket. I mean, yes, that's what it did, but it was a bit tricky to find that. And what that would simply allow you to do now was you could start a Haxe server by using Haxe with the command wait and then a specific port, which would set up a server that was waiting for connections. And connections could be made by using Haxe with -- connect to that port. And that would then basically do a normal compilation, but it requested all the information from the server, which would try to, this is missing some line again. Ah, there it is. I'm not sure why that happens. It tried to keep compiled information in memory to save time, so it wouldn't have to recompile stuff. And that is still the basis for what we do today, actually. And consequently, it would only recompile the stuff that actually changed. Or at least that was the idea. And then what we wanted to do was that IDEs could start a server instance and then send requests to it by themselves. Because this whole Haxe connect thing, you didn't really need that. All it did in the end was open a socket to talk to the server and then process the result in some way. And IDEs could do that by themselves. So they wouldn't have to boot up a process. They would just have to open a socket. And well, the compilation server saw a lot of minor improvements over time, of course, like everything in Haxe did. And by now, it's mostly okay. At certain times, there was a bit of an internal joke about it only working for Nicola. But I think we've reached a point where it's working mostly. I'm going to talk about it again in a bit, but for now, let's set the compilation server aside and look at some big issues as I've labeled them, because what also happened in 2011 was that two issues were opened. One was labeled top level completion, and the other was labeled IDEs, services, find references, which was actually opened by Philippe, one of the maintainers of FlashDevelop. And this was one of these things where everyone was like, this is a good idea, and we should definitely do this. But as it turned out, everyone wanting something doesn't necessarily mean that it's going to happen, because not much happened. We had a bit of an phase from about 2011 to 2014. And it wasn't until then that was actually me made a commit in May, which was labeled at top level completion, resolve positions for position usage completion. And this commit addressed these issues, and I think actually a few more even. And the idea, well, first of all, of course, we were committed to using this display argument because that's what I found when I arrived at Haxe. So I figured this is what the people around here do. So we kept rolling with it. We now needed more information. We didn't only need a file and an offset, we also needed the kind of compilation we wanted. So naturally, we separated that with another add, and then the mode, which seemed logical at the time. And the way it would work is, instead of the parser failing and inserting a display nodes, we would simply check, well, not simply actually, but we would check because we received the position we wanted from the display argument, we would try to find the expression that lived there. So after parsing, we would look at the AST and then find exactly where the user wanted to have the completion. And then again, the typer, when coming across the display thing, would do something depending on which mode we were in. And of course, it would output more XML because that was what we had at the time. And so we again rolled with it and made it output XML. The other issue I mentioned when talking about FlashDevelop was that you had the compiler needed to have the display file available as a physical file. And we wanted to get rid of that requirement because it's really impractical. If you think about it, if you're working on a file, you typically don't save it after every keystroke, and neither does your IDE. So having to save it wherever, only so the compiler can find it, is pretty silly. We didn't want to do that. And then somebody, I'm not sure who it was actually, it might have been Nicola or Dan, had the idea to write the content of the file to the processes, the server processes that is, Stdin instead. And this was then authored and committed by Nadako and me in 2016, the display Stdin commit. And we were, of course, still using the display compiler argument, only this time we would be adding the display Stdin thing. And now the compiler, I think this is actually quite easy to understand. If it was about to parse the display file, it would instead check if there was information on Stdin and use that instead. Sounds simple, is simple, wasn't so simple in our architecture because we had to get the right information to the right places, which was a bit messy, but we figured it out in the end. And it did actually help. I can say that much. And then we entered a new era. We're still in 2016, so that's 5 years ago by now. And that was when Nadako made a commit, which was simply named initial commit, which is not going to tell you much before I tell you which repository this was to. And of course, it was the VS Haxe repository, which he started. And VS Haxe is a language server. It's not just a language server, it's actually a complete plugin for Visual Studio Code. But the most important part here is the language server part. And the language server would be something that mediates basically between the compiler and the IDE. So the IDE understands how to talk to the language server, and the compiler understands how to talk to the language server, and that connected these two. It was a really nice abstraction in the middle that we didn't know we needed, but once we've seen the design, we were like, yeah, this is actually exactly what we needed. And it was very good that Microsoft designed that for us because we're notoriously bad at designing things like that. Of course, initially, it would just work with Haxe's XML output and the display API. By now, I'm using quotation marks around API because, well, we now needed sometimes even more information. We didn't only need a file and an offset and a mode. Some modes also needed additional information. And what was the logical thing to do? We would just add another add and then the additional information, because that's what we had and that's what we did, and it was glorious. We then realized at some point that we shouldn't be using XML as an output anymore, because Visual Studio Code, being a very JavaScripty thing, of course, was using JSON. So we figured, well, we should probably be using JSON as well. And this entire thing was a bit of a mess. We had some modes returning XML, we had others returning JSON. I remember some particular bug where we actually had XML inside JSON. I still have nightmares to this day from that. Yeah, it was a bit messy. So at some point, well, before we get to at some point, what it did allow us to do was implement actually quite a bit of features quite quickly. We already had at the point completion, go to definition and find references, and some other obscure stuff that I don't even really remember. And then during 2016, 2017, we very rapidly actually added proper top-level completion, which worked a bit differently. We added signature completion, so when you made a call, you would actually get a proper signature, and this would also support overload signature, so you had multiple and stuff like that. Then we also added module symbols, which allows you to, it's a bit in the middle of, Alex referred to full text search, and stuff like find references is a very type-focused thing. Module symbols is a bit in the middle of that. It looks at the parse AST, so it is aware of the syntax, and it just allows you to find identifiers, which I find very useful because, well, it just shows you what you need oftentimes without having to go through typing and all that stuff. And we also added its big brother, which is workspace symbols, which is the same thing, but at the project level, basically. We also added diagnostics, so errors would not just stop compilation and show up somewhere in the console, but instead show up in some diagnostics panel, and other information as well, which previously, most importantly, warnings, I suppose, would also show up as diagnostics. And we also added statistics, which showed you how many overrides does a specific method have, or how many child classes does some class have, things like that. And at this point, I really have to say thank you to Nadako and the infamous Gamma 11, Jens. They worked on this with me a lot, and it was really pleasant to work with them. They focused mostly on the VS Hex side of things, while I focused from the other direction on the Hex side of things, and we met on the language server, as I've described. And that worked really well, and that's why we made so much progress. And then at some point, we realized, man, this whole XML stuff, it's really silly that we have to work with JSON and XML. We should get rid of that XML. And in 2017, we added a new macro interpreter, eval. I talked about this in Amsterdam. And the reason I mentioned that is because it came with a debugger that used the JSON RPC protocol. That stands for remote procedure call. So we already had that implemented in the compiler, thankfully. And this allowed me to, in 2018, then start working on JSON RPC support. And now, don't be scared, I'm going to show you a short portion of OCaml code. This is the implementation. Here you can see again, I'm not sure if you can see my mouse cursor, but anyway, you can see the -- display thing, which is still a thing Nicola added back in 2007. And now, the argument he added a week later, what we will now do, this is all we did and still do, is check if the string starts with a bracket or a brace, we would then pass the input using the new JSON thing, and otherwise we will just do what we did before. And that was all we needed to get this working. So we had these two kind of tracks, we still do mostly, which is a bit annoying to handle, but it allowed us to support certain stuff on the new protocol and don't have to worry about the old protocol anymore. And that was really convenient. From then on, one of the biggest focuses has been to stabilize the compilation server. And I'm just going to show you on the slide a few commit log messages, actually. From 2019, there were commits like turn server ML into something readable. And then from Nadako, implement wait connect. It says wait connect. I believe what he actually committed was -- server connect. The thing was, I've told you about the wait command. And the problem with that was that you had to specify a specific port. And finding a free port is actually surprisingly difficult if you don't bind it immediately. Because how would you really do that? That proved to be a bit of a mess. So we would inverse the control. So the IDE would basically start the server itself, because then it knew which port that server had, and then tell Haxe to connect to that. And this was a very important change. Then there were also changes like this: track working memory and adapt overhead. This is related to garbage collection stuff. It is one of the most complicated commits, not in terms of code size, but simply in terms of what it actually does. Because as it turns out, if you have something like a long-running server, you have to worry about memory to an extent, because your memory can fill up and it can fragment, and at some point you have to compact it, and doing that is slow and things like that. So I spent quite a bit of time thinking about that and optimizing that. And something else I also did in September 2019 was start on socket polling, because what we had at the time was that whenever the server was waiting for a connection, it would block. It wouldn't do anything else. So it couldn't do any kind of cleanup or optimization. It just has to sit there and wait. And we had to overcome that by implementing socket polling. And this then allowed us to start working on what I called server tasks, which were basically small maintenance tasks that the server would perform on itself to optimize memory or to get rid of some stuff it no longer needs and things like that. And we then used that to, this is a garbage collection change I just mentioned, to turn that into a low priority server task. So the server would now, it would check, is there any display request? If so, handle it normally. If not, try if you can do something to clean up your memory or something like that. And this really helped a lot to reduce overall memory consumption. And I just wanted to show you these kinds of commits, because I talked about this in April. This does not look impressive in any release note. If I talk about how we implement working memory overhead adaptation, it's whatever, it doesn't sound impressive. But this kind of stuff always happens behind the scene, and it's very important that it happens. So I just want to let you know we're doing this kind of stuff, even if we don't talk about it normally, because it's not very interesting normally. And then finally, we have what I call invalid invalidation. The problem here was that many features, many display features and IDE support features depend on checks during type loading. For instance, if you hover over a type hint, the way it would work is the compiler would try to load that type, then check if we want to have IDE support for that type, and then do something specific with it. Naturally, in order to achieve that, we would have to invalidate our display file. And that then might also invalidate everything that depends on that display file. This is particularly silly for something like Hover, because imagine you are opening some random file in some library and just want to hover over a function argument for some reason to see what type it has. And Haxe would then invalidate that particular library file. And then everything that depends on it will no longer be cached. And it also wouldn't be recached until you made a proper compilation again. Because in display mode, everything we do is very reduced. We don't do proper compilation really, if we can help it, simply to make it faster. So over time, you lost more and more types, and compilation got slower and slower, and then until you recompile again, and then it will get faster again. This still is a bit of a problem to this day, but the changes we were working on here certainly helped. Because what we wanted to do is, can we just fulfill the request with the information we have without just doing everything again that we did before? And there's something missing again. This was actually requested by InnoGames in August 2019, because you guys had this problem on your code base, and on larger code bases, it was more of a problem, of course. And it was then implemented by me in November, which was named Implement T-expression-based display support. And T-expression means basically typed expression. It is our way of representing everything that we typed in the compiler. This is what we persist on the compilation server. And basically what we would do is find the thing that had the position that the user requested. Again, sounds pretty simple. It wasn't all that simple, but we managed to work it out in the end. So we are in 2019. We are almost at present day, so a bit more recent history. We received another issue, which was labeled server invalidate calls path unique key create for every cache module. This was also opened by InnoGames. We checked it out, and my first conclusion was, well, it seems fine on Windows. And apparently it was fine on Windows. And so nobody really noticed it, because funnily enough, most Haxe users, core developers, actually use Windows for some reason. That usually never happens. I'm not sure why that's the case for us, but it is. And then actually that was Andre Keller of InnoGames. He pointed out that while what we are doing for unique key create on Windows was just a string manipulation, it would involve file system operations on Unix OSs. And that explained why everything was so slow. And then, armed with that knowledge, Alex managed to fix that in June by optimizing path unique key create. And that made everything way faster. And of course, there were plenty of other improvements, some minor stuff like add something that looks like a Javadoc parser, because we actually didn't have that. And then since November 2020, we did have it. That's it for the history. Now, going forward, there's a general consensus that we don't really need more features. Of course, that doesn't mean that we're never going to add new features, but we agree that what we need is first and foremost more stability. And as I've said before, this is never going to look impressive in the release notes, but it's very necessary to do. And the most important thing here is to figure out how to improve caching, so we don't invalidate so much stuff on the server, because that's still a problem. We want less invalidations, especially from dependencies. So if you do something to some file, you don't want to invalidate everything that depends on it, because that cascades really badly, and then nothing is cached anymore, and then everything gets slow, and that's bad. So one of the ideas is to only invalidate something if its signature actually changes. If you think of a function, it has a specific signature, which is basically its type. And if only its implementation changes, you shouldn't really have to recompile anything else, because that's not going to influence anything, except for cases where it's inlined or something like that. But generally, this is safe to ignore then. The problem is, how do we figure out if only the implementation changed without doing everything we don't want to do? Because even the most minute change, like changing the type of a local variable, could change the return type of a function, given that type inference is a thing. So it's not really clear how to go about that. And it's certainly going to need some more brain and engineering power. And I'm going to leave you, well, I did think about that quite a bit, and I ended up drawing diagrams to help me understand it. And that then looked like this. And I was like, okay, what information can we get from that? And I managed to find some, but I just want to say it's not very easy to figure out what information has to go where, what has to be persisted, what can be cached, in which circumstances, what can't be cached, what has to be invalidated. This is a bit of a tricky subject. We're working on it. There's not much observable progress generally, but I'm positive that we will find a solution for this at some point. Just be a bit more patient, please. That's what I'm trying to say. And with that, I have one final personal note, because I'm going to make another commit, so to speak, in 2 weeks exactly, when I'm going to commit something named the Emerald Divide, because we actually made an album, and you can go to neoval.com and find out more about that. If you want to hear this wonderful lady sing, you can head on over there. And with that, sorry for the shilling, and thank you for the attention.
Shameless plug.
Shameless plug.
Better shameless plug than a shameful leak. Oh, I can't see. Wait, I left the questions.
Yeah, you should bring the questions.
It's late. Bedtime.
Thanks, Simon, for giving such a thorough update on the history of IDE.
You are very welcome.
And also,
questions,
sneak peek in the future. It's really great to see that you are actually like planning to work on at least like stability and optimization and improvement of speed of the IDE. When I saw this diagram, I wanted to ask you, because you are trying to kind of figure out the way how to how to make it happen. Is there something that you can learn or you can check how the other languages are doing, so you don't need to like figuring out all yourself, or it's like something that is really specific for Haxe?
I think it's pretty specific to Haxe. I mean, you can always get general ideas and abstract ideas in a sense, to be sure, but I'm sure we can learn something, but I'm not sure if that's actually easier than figuring out the solution for our specific problem. So maybe is the answer.
Okay, thanks.
Okay.
So we have no questions, it looks like.
Nobody.
Everyone
Okay.
is so overwhelmed.
That's fine. Yeah.
So, oh, here, can multi-threading be used for server compilation?
Multi-threading be used for server compilation? I'm not sure what he means, I have to say.
Can you specify, Larry?
I mean, I'm sorry. Multi-threading.
Well, maybe I can shed some lights on this. Do you hear me?
Yes,
Yes.
Go ahead. Thank you.
Okay, so OCaml naturally doesn't support multi-threading in the way we all used to in other languages, and at any time there can be only one thread running OCaml generated code for now, but there is a branch in OCaml development which would bring full-blown multi-threading to OCaml world, and then maybe we could adopt that. But for now, I don't think we can do that.
Yeah, okay. If you're referring to that, yes, of course, we don't have multi-threading on OCaml, unfortunately, which is one of the biggest limitations actually of it. So yeah, we have to make do. All right.
I think
that's it.
Yeah.
Then I have to say again, thank you, InnoGames, for organizing this. I didn't say it the entire thing.
Only
No.
once.
Yeah. So I'm going to say now, thank you for doing this. It's very important to show this kind of presence and be like, hey, here we are, and we're still doing Haxe stuff. And thank you, InnoGames, for doing that. And I'm going to shut up now. So who wants to do the outro?
I say thank you first also, then Finn is doing outro. Thanks for you guys for supporting. Thanks for great presentations today. I really enjoyed it, and yeah, looking forward for the next Haxe in next year. And yeah, thanks and have a wonderful.
Yeah, when are we having the next one?
Yeah, we should schedule it like right away.
I kind of want to know, like
next year.
Sometime next year.
Is it precise enough?
Yeah, it's always difficult to fit it in, I guess. Yeah, so what are we going to have a Haxe Summit? Well, if we're ever allowed to sort of like puppy pile on each other without serious regulations and fines and stuff, like I was thinking about it today. It's like, is this ever going to be a thing again? I think at some point it's going to be a thing again, but for now,
nobody knows.
Nobody knows. Like when we make it through the Christmas markets without sort of like, you know, extra regulations, then we know we're fine. Like when the Glühwein thing is, that's how we know. And then like the year after the Christmas markets are okay, we're having a Haxe Summit. That's how I'm gonna.
That's an announcement.
Exactly. So is the Haxe community growing? Well, you are here and I've never seen you before. So yes, I guess.
I think it's pretty stable at this point. I wouldn't say it's growing, but.
Hi, see, nice to meet you all. And nice to meet you. See, no, it's growing there. You are proof positive. No, I mean, it's, so I don't think it's exploding. However, every now and then, I'm not so in like the normal sort of day-to-day of the compiler team, but every now and then I'll kind of catch a glimpse of oh, who is this person? This is so funny. When someone starts doing commits on GitHub and like really good pull requests, and then like the compiler team kind of starts to go like, who is this person? They're like doing all these useful things. Have you seen them before? Does anyone know who they are? Where did they come from? Like that has happened several times that people just showed up out of the blue and started fixing stuff or committing stuff, contributing stuff. So yeah, that's always happening. And I think in terms of like on the kind of enterprise level, I mean, like there are now significantly more Haxe developers at InnoGames than there were 3 years ago or even 5 years ago. Like I remember meeting InnoGames for the first time, which I believe was in 2017-ish when their whole journey started. So like, yes, they have grown the community also. So have our other partners. And so can you when you tell everyone about Haxe. Yeah, so it's really good. It's good.
All right, then I think it's time to say goodbye, unfortunately.
Yeah, time to say goodbye.
Check out our album, neovel.com.
All right, see you later, guys. Love you all.
Have a nice evening.
Bye.
See you.